Welcome to Bun-Bun Island. Population is currently 4. This here is Spring. He's a 1-year-old white rabbit who has just been born. Spring is currently roaming the world, but he is starting to get hungry, so he's going to start looking for a snack. There's plenty of grass here on Bun-Bun Island, and he's going to look for a perfect spot to eat. Now that a year has passed, Spring is old enough to start thinking about settling down with a family. He'll only be able to mate with another healthy bunny older than 1 year, and I think he's found the perfect match. You might want to look away for this part. Now Spring is the proud parent of 2 healthy babies. Spring is coming to the end of his life now. He's lived a good few years and will die of natural causes. So now the population is somewhere around 65. Things are starting to get a bit crowded. Although grass will regrow, it takes 120 seconds of game time, which is over a year's simulation time, and it seems there's not enough to go around. The population has now decreased immensely because of a lack of food, but things are starting to regrow, which means the population cycle can begin once again. The inspiration for this project came from my AI module lecturer, who mentioned a hunting simulation as a good experiment. Similar simulations have been made in Unity by many other programmers. I decided to design my concept before watching any of these videos, so that the vision would be my own, and then reference them afterwards if I needed to see how a certain mechanic was handled. The rabbit model was created in Blender, and the grass and dirt textures for the tiles were sourced from textures.com. Most of the issues I had were solved by asking fellow programmers for advice, searching the Unity forums for similar problems, and good old trial and error. Bun-Bun Island is set up on a simple plane with a mesh render component added to it. If we go to the navigation tab, you can see the area in which the rabbits are allowed to navigate. Each rabbit is given a nav mesh agent component, which specifies that the model cannot move outside the boundaries of the navigation area. Each rabbit is a prefab with an AI script component. The nav mesh agent is assigned by the inspector, and each rabbit will receive a target when moving, which their position is transformed towards. In the AI update function, the rabbit will pick a state based on its stat handler script, which manages the variables of each rabbit. The first state is an idle state, in which the rabbit is given a random position on the plane that will change every 5 seconds. The next state is a hunt state, in which the rabbits will search for food if their hunger stat drops below a specified threshold. Grass tiles are split up into tile prefabs and added to a list when they are created, which the rabbits have access to. When a rabbit gets hungry, it will pick a tile at random from this list and set its target for the tile. When the destination has been reached, the tile is changed to dirt and the rabbit receives some of the hunger back. A boolean will change the tile to dirt, which changes its texture and tells the rabbits there is no food available on this tile anymore. The grass tiles originally took 30 seconds to regrow, but I decided to change this amount to 180, which is much higher, because the rabbits were surviving too easily. Rabbits have an energy meter, which will need to be maintained by going into a sleep state. If a rabbit's energy is below their energy threshold, their target is set to their current position and the sleep animation will play. Once they are fully rested, they can go back to any state, but if their hunger is also below a certain amount, they will not be able to sleep and will need to hunt for grass first. Each rabbit has an age that starts at 1 and goes up by 1 every 30 seconds, or a year in simulation time. Once a rabbit is over the age of 1, they will be able to go into a mate state. The rabbit will pick a suitable mate from another list that has each rabbit AI inside. If the selected rabbit isn't itself, and its partner is healthy and also older than 1, the rabbit will set the target to its mate. A heart icon is displayed, and 2 new rabbit prefab clones are instantly created of the same color as the parent. Mating uses a lot of energy, so rabbits will likely need to rest before they can mate again. Energy and hunger is going down every second, so rabbits will need to manage their stats before they reach 0, or they will go into a dead state. The target position is set to itself, and a cross appears above its head. Once 4 seconds has passed, the rabbit will remove itself from the list of potential mates and destroy itself. Rabbits will also die if their age reaches a maximum age, which is a random variable assigned at birth between 4 and 7. The game starts with 4 rabbits of 4 different colors. The idea here was to have each rabbit have different stats which are passed down between generations to see which rabbit color had the best survivability. But this idea has not yet been implemented due to time restraints. As mentioned though, the rabbits will pass down their color genes to their children. All code is handled dynamically, meaning although some variables are assigned in the inspector, it is all handled on the C# side. The biggest problem I had trying to code this solution was managing the lists that the AI script had to access. Many data structure techniques were needed to handle this, and I found this is where I had to spend most of my time, as I wanted the code to be neat and dynamic. As a result, there was much trial and error involved, and I'm sure that some scripts and code are likely now redundant and will need cleaning up. Although I thought I did my best to fix all the list issues, there still seemed to be some bugs present with later rabbit clones not being able to destroy themselves or finish their dead state. For example, in this sped up footage of one simulation, you can see the population increases to around 40 and food sources start to run out, so rabbits are starting to die. Once it's gone back to around the starting amount of 4, there are still plenty of grass sources, but the rabbits are either not moving or stuck in place. We'd expect them to start repopulating, and the cycle would repeat. I think this could be due to the rabbit's target getting attached and stuck to an already destroyed rabbit. The rabbits also struggle to move to their set location when there is too high a rabbit population. The original idea was to have animal as a base class, prefab, and have rabbits and foxes as part of the simulation. Foxes would hunt the rabbits, and the rabbits would need to be able to evade them. The mechanic was scrapped due to time restraints, but can likely still be implemented. I wanted each year each rabbit was born and died to be recorded to a text file, which I would have access to after the simulation had ended. This way, a graph could be calculated showing the population of each rabbit color, as well as prove the theory that the population is based on the food source. I am quite pleased with how the simulation turned out, but there is plenty of room for improvement overall. I think if I were able to start the project from scratch, there are many methods I have learned through the creation of the project that would likely aid me, and the solution would be much cleaner. As it stands, there are some very complex techniques at play under the hood, but I think ultimately the complexity of the code was the downfall of the features that I wanted to implement, as I spent most of the time handling errors and lists. I really enjoyed coding this project and would like to return to it in the future, perhaps once my studies are completed. Thanks for visiting Bun-Bun Island.